Welcome back to day 15. I'm thrilled you're here. Today, we're moving from static code to dynamic automation. If you've ever wondered how programs process thousands of files or send a million emails at once, the answer is loops, specifically the for loop. We're going to break down how they work, why they're efficient, and how to use the range function to control them like a pro. In Python, a for loop is used to iterate over a sequence. Think of a sequence as a list of tasks. The loop looks at the first item, performs an action, then automatically moves to the second, the third, and so on until the list is empty. This is called iteration. The syntax is simple, for followed by a variable name you choose, the word in, and the collection you're looping through. And remember that colon at the end, it's the gateway to your loop's body. Let's look at a live example. We have a list called fruits. Instead of printing each one manually, we write for fruit in fruits. On the next line, we indent this is crucial and write print, fruit. When we run this, Python assigns an apple to the variable fruit, prints it, then goes back to the top for banana. It manages the counter for you, making your code incredibly clean and readable. Now, what if you don't have a list? What if you just need to repeat something 10 times? This is where the range function shines. It's a built-in Python tool that generates a sequence of numbers. If you type range 5, Python creates a sequence from 0 up to 4. Notice it stops before 5. In programming, we start at 0, and the stop value is always exclusive. This is a concept that will serve you well across almost every programming language. The range function is more flexible than it looks. It can take 3 arguments, start, stop, and step. For example, range 2, 10, 2 tells Python, start at 2, stop before 10, and skip every 2 numbers. When we run this in a loop, we get 2, 4, 6, and 8. Using the step argument is perfect for filtering data like finding every even number in a dataset or skipping rows in a spreadsheet. Let's try a real logic challenge. How do we calculate the sum of numbers from 1 to 10? We use an accumulator. We create a variable called total and set it to 0. Inside our loop, we say total plus equals I. Each time the loop runs, it adds the current number to our running total. By the time the loop finished, total holds the sum of all iterations. This pattern is the foundation of data analysis and financial calculations. Accumulator. We create a variable called total and set it to 0. Inside our loop, we say total plus equals I. Each time the loop runs, it adds the current number to our running total. By the time the loop finished, total holds the sum of all iterations. This pattern is the foundation of data analysis and financial calculations. Now, let's step up the difficulty, nested loops. This is a loop inside another loop. Imagine a clock. The seconds loop must finish 60 iterations before the minutes loop moves forward by 1. In code, for every one time the outer loop runs, the inner loop runs its entire sequence. We use this for working with grids, coordinate systems, or even building complex multiplication tables. Look at this grid on the screen. We have an outer loop for the rows and an inner loop for columns. As I run this, you can see how the inner loop completes its 0, 1, 2 cycle while the row remains at 0. Then the row moves to 1, and the cycle repeats. Mastering this logic is what separates a beginner from someone who can build professional-grade algorithms. Before we wrap up, a few expert tips. Always name your loop variables clearly. Use for student in student rather than for x in y. It makes your code easier to read for your future self and your teammates. Also, be careful about modifying a list while you are looping through it. It's usually safer to create a new list for your results. These small habits are what build a professional identity in the tech world. That brings us to the end of day 15. Now it's your turn to put these concepts into action. Head over to the description below to download today's practice files and start building your own loops. Don't forget to share your progress and connect with our community on LinkedIn. Keep practicing, keep coding, and I'll see you in the next lesson.
Thank you for watching. Like if you learned something, share with your circle, and subscribe for more.